Hi, it's Mrs. Davis again. This is the second video in our graphing set of videos, and I know the first one was kind of more of an assignment and then the video was to help you out, but it's my hope that now that you've done those graphs and you've worked through them, you can now look at your own data and decide what type of graph you need, and then you'll know how to make it. So that's my hope for this second video. So obviously here I had it marked as number 1, but I couldn't quite figure out which one to make it, so it's actually going to be number 2. Anyway, so let's go right ahead into this. The first thing you need to do is look at your data tables, and you need to make sure that they're set up well. We went through this and you submitted them and you got a grade for them, and hopefully that means that you had a main title, you had your variable titles, and you have units for everything. And you can see here, this one has the title. If you have dates here, you know, you don't really need a unit there, but other times you will need a unit, like centimeters, and then all the data is there. Okay, so check and make sure that you set up your data table really well. If you have more than one data table, you can take a hint from here and number that data table so that you know what data table is what. All right, and then the dragon here reminds us that your data tables will go on your board, so make them really good. They need to be set up nice, they need to look nice, it needs to be very obvious what's going on in those data tables. Okay. Now, this is just a reminder and a review of how they should be. Usually, you should have your independent variable down here with your different versions listed, and then your trials, and they call them readings here, and then an average. Now, that doesn't mean that your data table is going to look exactly like this, because you might have a different version of it. That is okay. Data tables should fit your individual experiment, so yours might be different than this, but this is kind of how it should be. Okay, and there's an example where we've got your title, the effect of one thing on another thing, or average is calculated, you got light color and a unit there. So that's set up really nicely. All right, and then one of the things that happens is sometimes you need to calculate something. And so you might need to make a whole new data table just to calculate your what we call derived variable, okay? And sometimes you need to calculate an average. In fact, almost always, you need to calculate an average of some sort. And so to do that, again, you need to add up the results of the trials for each variable and divide by the total and repeat it for every variable after that. Okay, so that's how averages go. You can use Excel to calculate the average very easily. All right, another thing you might need to calculate here is that you have an equation that you need to apply. And that means that maybe I need to calculate something like a density or a speed or a flow rate. You can make a copy of your data table and use Excel to make the calculations, or do the calculations by hand and then enter them into a new data table or the same data table with a different column. You'll just have to figure out how the best way to do that is going to be. Okay? Now, sometimes we have data that we call qualitative. That means it's been describing something with words or senses, and it's really hard to get a number to measure it. All right, and so it can be kind of tricky to figure out what kind of graph you need for that. It really depends, but almost always you can make some sort of graph out of something. Okay, for example, a yes or a no answer can be turned into a 1 for a yes and a 0 for a no, and then this is kind of like the one that you did in your assignment. You can then turn that into a graph of some sort. This isn't the final version of the graph that you guys made, but it's along those same lines, where 1 means yes, it lifted, and 0 means no, it did not, and so then there are your different trials. So that's one way to turn qualitative data into a graph. Another way is to rank something on a scale of 0 to 5 or 0 to 10, or in this case it's 1 to 5 stars, and then they counted how many people gave them 1 to 5 stars. And so that's another way that you can use qualitative data, where maybe you have the bubbles in a chemical reaction and you can rank those on a 0 to 5 scale. Okay. Now, another way to do qualitative data is something called a frequency table. How often does a certain response occur? Okay, and an example of this is the favorite colors that we did on our graphing assignment. Frequency of favorite colors is listed here, and then it tells the percentage of all of the respondents that gave that particular response. So you've got your people that gave each color here. This is different than the one we did, and then it calculates a percentage automatically in a pie graph. And so that's another possibility for qualitative data. Now, by the time you finish doing your graphing, I know this is looking ahead a little bit, but you're going to be able to write about your findings. Your paragraph that you write here will go on your board, and so it needs to be a nice paragraph, and you're going to put this in with your assignment for making your graph. But you want to put in there trends that you see. And by trends, we mean do your numbers increase every time? Do they decrease every time? Do they go in a curve shape? What is the trend overall that you see with one variable in relation to another variable? Okay. What does your data tell you about your experiment? Were you right or wrong in your hypothesis? Either way is okay. You just have to report it out. And then you might want to talk about your data in terms of errors that you might have made. It's important to be honest about science fair projects and what things you might have done wrong so that you know what you might do differently in the future. Look for the sources of the errors. If you know how to calculate your accuracy or your precision, you could even do something along those lines. If you have like an accepted value, you could calculate percent error. All right, you don't have to do that, but it's something that's possible to do. Okay. All right, so your choices, the types of graphs, you've seen all these. You got pie charts, the possibility. You've got scatter plots or line graphs that are a possibility. You've got bar graphs that are a possibility. Now, of these three, there are situations that would call for either one of these. Your pie charts are best when you're trying to compare the parts of a whole. All right, this is less common, honestly, in science fair. It's just not used that often. But when you do make a frequency chart with that qualitative data, you might need a pie chart. Okay. And like the dragon says, they're not usually found in science fair. Now, a line graph or scatter plot is common in science, okay, because it shows very clearly the relationship between two variables. And in this case, you're looking at temperature versus money. In this case, you're looking at time versus water level of a cylinder. And so you've got your two variables, and you're trying to figure out the relationship between the two. And that's where line graphs are really important. And we can learn from those how they are coordinated with each other. Do they increase together? Which one of these would increase with the other one? It's actually this one would increase as they're both increasing. All right, they're both going up. And then the other option would be, does one increase as the other decreases? Okay, and or they might both decrease. But as you can see for this one over here, okay, one is going up, the time is increasing, but the height is going down. And so there's that downward trend there that we see. And that's important to notice that overall trend. Are these two things related somehow? Okay, so line plots and scatter graphs are important for that. And in general, this is not always true, but because there are exceptions to every rule, but we don't usually connect our dots in science, okay? We're looking for relationships, okay? We're looking for either, a linear relationship or an exponential relationship that curves upward, or maybe there's kind of a bell-shaped thing going on. There's a lot of different possibilities, but we want to know if there's some sort of pattern, okay? And that's the key to all this, as we're looking for patterns. And so when we connect our dots, it's less likely that we are going to see that overall pattern, all right, especially when things get more complicated. Okay, so lines are drawn as straight or curved. We don't usually try to connect our dots. Sometimes you can. So when you do that, you also draw a line through as many dots as you can. Now, when you do the scatter plot, these are called trend lines. and it does it for you. You don't even have to think about it. And so using Excel for this is really important. All right, so they don't have to touch all the points when you're drawing these lines, but they should come close if you're doing it by hand. All right, this is called a best fit line. The kind of graph is called, like I said, scatter plot or scatter plot with the trend line. Okay, and so you want to always make sure you add that trend line in. Okay, and like I said before, you might have a curve. Not all scatter plot graphs have to be a straight line. Sometimes you might have nonlinear or exponential functions, and you can see the pattern in here. Notice how much data they took here for this, whatever this experiment was. That's a lot of data points. And real science, they take as many data points as they can get, because that is going to give you a better idea of what is actually happening. And you wouldn't be able to see this trend if you only had 3 data points. But with thousands of data points, they can see it. Okay. Bar graphs are used to compare variables between different groups. This is often a good choice for science fair. It's easy to read. It can sometimes be used instead of a line graph if the situation's right. But in this case, we have different categories. It's not numerical, so this is perfect for a bar graph. Also here, this is time, but we're talking about average temperatures in months, and that works really well for that, okay? This one, you did an exercise like this in the Excel worksheet, but this is a situation where it shows the different trials and the liquids versus the other option, which is to have the different liquids grouped together. And you can see here that it's just a little bit easier to see the overall trend. Obviously, coffee on average is more than water. And so when they're grouped like this, it's a little easier. So this is kind of how I prefer that you show your graphs. You have your different independent variables along the bottom and your dependent variable along the left. Your trials, you should not sort by your trials. Okay, trial 1, trial 2, trial 3 should generally not be under here. All right, so how do you choose what you do? If you take a look at your data. Did you take data over a period of time? Okay, often then what you're going to want to do is take a scatter plot, do a scatter plot with the best fit line. Okay. Did you have a continuous range of values? Then you're also probably going to want a scatter plot with the best fit line, although a bar graph might work here too. Do you have independent variables? Does your independent variable have categories or fixed values, like low, medium, or high? You're going to want a bar graph. Are you looking for how often a certain event happens? You're going to want a pie chart for that. Okay? And then there's the other question of how many of all of these do you actually need? Well, the answer is as many as it takes. Okay? You want to show all of your data. And that's an important thing. If you are tempted just to like make a graph where you show everything all at once, but you're showing your average and only your average, then you're not really giving the whole story, okay? We want to have all of it. Everything that you did needs to be shown somehow in a graph, okay? So every trial in a graph. This doesn't mean you need to have them all on different graphs. You could, if the situation is right, put them all together on one. You also do need to show an average or a trend. Somehow, some way, you got to tell what's going on. You want to overall be able to use your graph to show your judge what conclusion you made and how you came to it. Was your hypothesis right or wrong? And is it wrong to have a wrong hypothesis? Absolutely not. You just need to use your data to support your claims. Okay? So when you're doing your graph, I want you to go through this checklist. Do you have all of your data showing in one or more graphs? Did you put a title at the top and on both axes? Are they capitalized? My pet peeve. Are the units of measurement included? Please, every time. Does it look good or better than it would if you drew it by hand? Some of you, that's an easy yes. and that it doesn't say much, but it really needs to look nice for your boards. Okay, and then did you write your analysis paragraph to go along with your graphs? That's a requirement for your grade. Okay, you need to just say what your data says in words. Okay, so just the final word here, if you want to print in color, only I have access to this, so if you want to print, you need to lay them out in a Word document, preferably all in one document, and then you can also resize them to know how it's going to size out, how it's going to print, and then you can upload those to the Word document in Canvas, and I can print that exactly as it would look. So play around with that and think about how that's going to look on your board, and I will print them off for you. All right, that's it. Thanks for watching.